Okay, this is 11.3. This is a pre-section on trigonometry, some review really quick for those of you that need it. So given a right triangle, it's a triangle in which one of the angles is 90 degrees. And I'm going to do this quick, hopefully within 15 minutes, review what you normally cover in 3 sections. So I'm going to touch on a few topics, but I'm going to start from the most basic. If I picked an angle, theta, depending on where I choose the angle, the side opposite of that I label as opposite. The side opposite of the 90 is the hypotenuse that nobody touches, and the remaining side, the side that's not an opposite of an angle, we call that the adjacent angle. So 3 triangles, 3 sides associated with every triangle, right? And we name them as follow. And associated with every trig function, with every right triangle, are 6 trigonometric functions. The sine of theta is the opposite side divided by the hypotenuse. And the cosine of an angle is the adjacent side divided by the hypotenuse. And the tangent of that angle theta is the opposite divided by the adjacent. The purpose of those initially was to find that angle. To find the angle theta, you could use sine, cosine, and tangent, and pretty much you will have any different combination of sides or of sides that are given. Between those 3 trig functions, if you were given the opposite and the hypotenuse, you have a trig function for that. If you were given the adjacent and the hypotenuse, you have a trig function for that. And if you have the opposite and the adjacent, you have a trig function for that. We'll do a few examples really quick. Now, associated with every trig function is a reciprocal function. Associated with sine is the cosecant of theta. That is the reciprocal. So it's really the hypotenuse over the opposite. And associated with a cosine is a secant of theta. That's the hypotenuse over the adjacent. And associated with tan is the cotan of theta. And that's the adjacent over the opposite. So, in any triangle, any right triangle, I could figure out any of those given 2 sides in any combination. An example. And the famous term to remember those, sine, cosine, tangent, is really SOHCAHTOA, provided you can spell it right. Sine is the opposite over the hypotenuse, cosine is the adjacent over the hypotenuse, and tangent is the opposite over the adjacent. So given the following triangle, if I would like to find the 6 trigonometric functions, first I know that the hypotenuse squared is 1 squared plus 2 squared from the Pythagorean identity. That's 1 plus 4, which is 5. And if I square with both sides, h will equal plus or minus radical 5. In geometry, length cannot be negative, so there it is. And I could say the sine of this angle theta is the opposite over the hypotenuse. The opposite is 1, and the hypotenuse is a radical 5. You could rationalize, you can't, that's not a problem. Cosine of theta is the adjacent over the hypotenuse, and tan of theta is the opposite over the adjacent. Similarly, cosecant of theta would be radical 5 over 1. You don't have to write that one, I'm just putting that down for your notes. And secant of theta would be the radical 5 over 2, and the cotan of theta would be the 2 over 1. Now, this is just a note. I could pick any of these triangles. If I pick this, I could say if sine of theta equal 1 over radical 5, then theta equal the arcsine of 1 over radical 5, or the inverse sine. That's not 1 over, that's what they got the notation from. And I'll plug this in my calculator. If I am in degree mode, I could figure out what this angle equal by using a calculator. I'll show you how that works. Or somebody might say, well, you know what, I don't want to use sine, I want to use tangent. Well, if tan of theta equal 1/2, then theta will equal the arctan of 1/2, or simply the inverse tangent of 1/2, and that'll do the trick. HP calculators use arc, TIs use inverse, and you notice when I plug in my calculator, they're roughly 26.6 degrees each. You can't get it wrong. So I could use any of those three triangles, sine, cosine, or tangent, to figure out any combination of this. To figure out the angle by using any combination. Now, we want to talk about two special triangles. If I take an isosceles triangle in which those two sides are the same and those two angles are the same. If I label this side 1, this side's automatically 1. And this side right here by Pythagorean would become radical 2. You could figure that out by taking 8 squared equal 1 squared plus 1 squared. But if those angles are the same and this is 90 degrees, that means they're 45 degrees each, or simply pi divided by 4. And if I take another special triangle that I need, 30, 60, 90, if I label this side 1, the hypotenuse is automatically 2, and the side opposite of the middle side, which is 60 degrees, is radical 3. And if I take the sine associated with 45 degrees, that would be, well, either one, it doesn't matter, let's say that one, the opposite over the hypotenuse. And the cosine of 45 degrees is also the opposite over the hypotenuse. And tan of 45 degrees is the opposite over the adjacent, which is 1 over 1. I don't know if you said it right. This is opposite over hypotenuse. This is adjacent over hypotenuse. If I look for the sine of 30 degrees, that is the opposite over the hypotenuse. That's 1/2. And if I take the cosine of 30 degrees, that's the adjacent over the hypotenuse. And if I take the tangent of 30 degrees, that is the opposite over the adjacent. Similarly, if I look at this from the 60-degree perspective, the sine of 60 degrees is the opposite over the hypotenuse. The cosine of 60 degrees is the adjacent over the hypotenuse. And the tangent of 60 degrees is the opposite over the adjacent. And those you could always derive by drawing those two triangles. And that's as far as geometry is concerned. Now consider a unit circle. In case you don't know what that is, a unit circle is a circle with a radius of 1, or you've forgotten that. If this is a unit circle, this is the point 1, 0. This is the point -1, 0. This is the point 0, 1. And this is the point 0, -1. If I pick a point on the xy, let's say right there, if I call this xy, which is on the circle, if I draw a line from the origin to that point right there, wouldn't you agree that this is the x and this is the y? And isn't that 90 degrees? And isn't this 1? Because that's the radius of the circle, unit circle. And if I look at this angle theta, wouldn't the sine of this angle theta be the opposite over the hypotenuse? And wouldn't you agree that cosine of theta is the adjacent over the hypotenuse? And isn't tan of theta the opposite over the adjacent? So, do you believe now that I could take this x and y, and if I am in a unit circle, instead of x, I could say that's the cosine of theta, and instead of y, I could say that is the sine of theta, right? And since I know that x and y are positive in quadrant 1, x is negative, and y is positive in quadrant 2, they're both negative, positive, and negative. Well, instead of memorizing that, look, cosine is negative in quadrant 2, positive in quadrant, I could simply, somebody came up with this awesome, quick, nice way of figuring this out by using all students take calculus. That is, all the trig functions are positive in quadrant 1, sine is positive in quadrant 2, which means cosine and tangent are negative. Tangent is positive in quadrant 3, which means sine and cosine are negative. And cosine is positive in quadrant 4, which means sine is negative and tan is negative. And on top of that, if I take this triangle and I copy it down, we said this was a 1. So this is the cosine of theta now, if that's an angle theta. And this is the sine of theta. And if I use Pythagorean identity, wouldn't you agree that cosine squared plus sine squared equals 1 squared? And that's the famous Pythagorean identity. You divide everything by cosine squared. Sine over cosine is tangent. 1 over cosine is secant. And you go back and divide everything by sine squared. Cosine squared over sine squared. Sine squared over sine squared. 1 over sine squared. And you could derive the rest from there. One more thing I need to show you. In trig, they say if you break this into 30 degrees, 45 degrees, and 60 degrees, along with knowing, again, this is still a unit circle, at this point, if you memorize, this is radical 3 over 2 1/2. This is radical 2 over 2 radical 2 over 2. And this is 1/2 radical 3 over 2. If you would have took me for geometry, I derive trig. I derive all of this. You really would know where everything comes in from. And if I take this circle and break it into 2 equal parts, and take this quadrant and break it into 2 equal parts, you could start by saying this is 0, this is 360 degrees. Right? This is half of it, 180 degrees. This is half of it, 90 degrees. This is half of it, 45. So 45 plus 45 is 90. 135, 180, 225 degrees, 270, 315, and 360. Or this is 0 and this is 2 pi. Half of 2 pi is pi. Anytime dealing with fractions, multiply by half instead of dividing. Multiply by a half, pi over 2. Multiply by a half, 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4, 6 pi over 4, 7 pi over 4, and 8 pi over 4. And if I go back to this and I break it into each quadrant into 3 equal parts, it would look, ignoring the green, it would look like this. So ignore the green, just focus on the red. This would be 30 degrees, this would be 60 degrees, this would be 90, 120, 150, 180, 210, 240, 270, 300, 330. And if I go back and say, you know what, this is 0, this is pi, this is pi over 2. I'm going to divide that by 3 or multiply it by 1/3. That would be pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6 when you reduce it, 5 pi over 6, 6 pi over 6 reduced, 7 pi over 6, 8 pi over 6, 9 pi over 6 reduced, 10 pi over 6, 11 pi over 6, and 10 pi over 6, and 12 pi over 6. You need to know those. I would love to do more, but this is as much overview I will give you, and everything else is in the first video of actually 11.3. So this is a pre-section.